Hello and welcome to another eMathInstruction Common Core Algebra 1 lesson. I'm Kirk Weiler and today we're going to be looking at Unit number 2, Lesson number 2, Seeing Structure in Order to Solve Equations. We're adding something new to our worksheets right now. We're adding a QR code which can be found under the date field. Teachers and students are going to really like the QR code because what it allows you to do, right, is to take a little app that you can get on your cell phones, typically for free, scan that code and it'll take you right to this video, right? Now, as always, the worksheet and a homework for this video can be found by clicking into the description underneath the video. So feel free to do that, download the worksheet, and if you need to see the video again, all you have to do is scan that QR code and your smartphone will take you right here. All right, let's take a look at what we're going to do today though. This is the first lesson where we're really taking a hard look at solving equations, right? Finding the values of variables that we don't know. And before we do this, I want to go through a little video where we take a look at something that happens to the number 3. Let's say we take 3 and we multiply it by 2 and we add 1 to the result, right? Let's just keep track of 3. Due to order of operations, right, we're going to get 6 first, and then we're going to add on the 1. And of course, the result, very simple, is going to be 7. Right? All right, this is easy enough. So let's say you had a number that you multiplied by 2 and you added 1 to, and the result was 7, right? You multiplied by 2, you added 1, and you got 7. How can you turn the 7 back into a 3? Well, ultimately, right, you would undo what you had done. So you'd subtract off the 1, that would get you back to your 6, then you would divide by 2, and that would get you back to your final result of 3. Now you might say, all right, what does this have to do with solving equations? Well, ultimately, my belief is that the final step almost always in solving any algebraic equation is to undo what has been done to the variable in the opposite order in which it's been done. So if I've got a number that I've multiplied by 2 and added 1 to, and I know the result is 7, I can just go backwards by subtracting 1 and dividing by 2, right? So you got 2 times a variable x plus 1 equals 7, right? You get back to x equals 3 by subtracting 1 from both sides, getting you 2x equals 6, then dividing by 2 on both sides, and obviously getting you x equals 3. So I want you to keep this in mind throughout the lesson today and throughout this entire course. At the end of the day, every time you solve an equation, your final step ultimately will be to undo what has been done to x. So look for that structure. And let's start to get some practice. Exercise number 1 says, consider the equation 5x plus 3 equals 23. Letter A asks us to list the operations. Uh-oh, what happened there? I thought we had our pen activated. Nope, let's get it going. All right, there we go. It says list the operations that have been done to the variable x on the left-hand side of the equation. So what's been done to x on that left-hand side just in the expression? I don't want you to worry about the equation. Pause the video right now and make a list. There's 2 things that have been done to x. What I want you to do is list them in the order in which they happened. Pause the video now. All right, well, due to order of operations, right? The first thing that happened to x was that we multiplied by 5, right? Yeah, 5 times x. And then we added 3, all right? It's important to note, you can't think that you've added 3 first and then multiplied the result by 5. That would be misinterpreting order of operations, and that's key because in B, when it says solve the equation by reversing what's been done to it, well, we say we've got a number. Think about that little video that you saw, right, with the 3. We've got a number that was multiplied by 5 and we added 3 and we got 23. What we're going to do is we're going to subtract 3 from both sides, all right? Of course, 3 minus 3 is 0, so we just get 5x, and 23 minus 3 is 20. And now what we'll do is we'll divide both sides by 5. 5 divided by 5 is 1, so that leaves us 1x equals 4. That's the solution to our equation. Of course, we can check that it's a solution to our equation by simply taking the 4 and substituting it back into our equation to see if it's true. Remember the last lesson, that's really all we did. We just talked about what a solution to an equation was. A value of the variable that makes the equation true. So 5 times 4 is 20, plus 3 equals 23. Yeah, I think we can say that's true, right? So ultimately what this boiled down to was identifying what had happened to x and reversing it. I'm going to scrub the screen in just a second, so take a look. Pause the video if you need to. Here we go, scrubbed away. Let's go on to the next problem. All right, in exercise number 2, we've got more complicated equations, right? And what I want you to do is in each case, I want you to identify what happened to the variable on the left-hand side of the equation, and then we're going to reverse what happened to the variable in the opposite order in which it happened. If you think you already know what's going on, pause the video now and try letter A. All right, let's go through letter A, because some of you probably are like, whoa, man, that looks horrible. But watch. If we look at the structure of the left-hand side here, right, we just key in on this, then what we notice is that the first thing that's happened, right, is that we've subtracted 3. Right, we subtracted 3 from x. Now, the next thing that happened was we divided by 2. Right? We divide by 2. And the last thing that happened was that we added 7. Did I just say that was 3? We added 7. So what we're going to do is we're going to solve the equation now by just reversing those in the opposite order, right? So a lot of students would look at this and they'd go, oh man, that equation just looks horrible to solve. But not us, right? We're just going to say, well, we added 7 as our last step, so as our first step, we're going to subtract 7 from both sides. Of course, 7 minus 7 is 0. You can add 0 to anything you want as many times as you want, and 13 minus 7 is 6. So we took care of that. Now let's divide by 2. Well, to undo division by 2, we multiply both sides by 2. Here we can just do what's called cross-canceling in fractions, and we'll just get x minus 3 is 12. So we got rid of that dividing by 2 by multiplying by 2. And the last thing that we did was we subtracted 3, so we're going to undo that by adding 3 to both sides. Some teachers, of course, will show that adding 3 underneath. That's quite all right. I go both ways. But we get x equals 15, right? So you look at this equation and it looks absolutely horrible, but when you break it down, when you look at the structure on the left-hand side, which is completely dictated by order of operations, completely dictated, then all you have to do is understand in your head what happened to x, and then how do you reverse it. So pause the video and try letter B on your own. All right, let's go through it. Well, what happened to x? We look up at this equation. We've got these parentheses here. That means that we have to do what's in them first. So we added 1, right? Now, once we added 1, then we have a choice. Did we subtract 2, then multiply by 4, or did we multiply by 4 and then subtract 2? Well, order of operations is pretty clear here. That multiplication, multiply by 4, comes next. Our last step was the subtraction by 2. All right, so now what we're going to do is we're going to undo each one of these steps by just reversing what's been done to it. The first thing that we do is we reverse subtraction by 2. All right, so we get 4 times x plus 1 minus 2, and then I'll undo that subtraction by 2 by adding by 2. Right? Here we can really look at this as negative 2 plus positive 2, which again ends up just canceling and giving us 0. So we get 4 times x plus 1 is equal to negative 4. Right? Let's undo that multiplication by 4, and we'll just divide both sides by 4. Right? 4 divided by 4 is 1. So we'll just have x plus 1. Negative 4 divided by positive 4 will be negative 1. Think about that a little bit if you struggle with negative numbers. And then, of course, we'll undo, there we go, I just did it in the below setting. We'll undo that addition by 1 by subtracting. Watch out here. Real easy to think that negative 1 minus 1 would be 0, but negative 1 minus 1 would be negative 2. All right? And again, I encourage you to go back and check each one of these by substituting them into the original equation and verifying that it's true. All right, I'm going to scrub the text from the screen in a moment, so get ready. Pause the video. All right, here we go. Let's go on to the next problem. Now, sometimes choice is not a great thing in terms of ways that you do a problem. A lot of times students want like one and only one method to carry out an algebra problem. And math isn't like that. Math opens up a lot of different paths for us. So I'd like to solve one problem in two different ways. I'd like to do it the way that we've been doing it, and then also do it a different way to just show you that there's more than one way to get through a problem typically. All right, so let's take a look at the equation -2 times x minus 4 plus 8 equals 2. We're going to solve this equation two different ways. In letter A, I'd like to do what we've been doing. I'd like to reverse what's been going on in terms of order of operations. And in letter B, we're going to use the distributive property. So what I'd like you to do is pause the video now. In letter A, I'd like you to identify what's been done to x and then reverse it to solve for x. Pause the video now. All right, let's go through that. Again, this is very similar to the last problem. When we look at what's been done to x, we see that we've subtracted 4. Now, I would imagine that many of you will eventually not need to write these steps out, that I multiplied by -2. And then finally, I added 8. So when I solve the equation, let me do that down here. I'm going to undo that process, right? First things first, we'll undo adding the 8 by subtracting 8 from both sides. That's simple, right? Watch out over here. But on this side, of course, every time we do this, we get kind of a predictable answer. 8 minus 8 is 0. Watch out here, 2 minus 8 is -6. Let's undo multiplying by -2 by dividing both sides by -2. All right, again, be careful. A negative divided by a negative, remember, is always a positive, and 6 divided by 2 is 3. And then, of course, we can undo subtracting by 4 by adding 4 on both sides. Again, notice all we do is identify what's been done to x and the order in which it's been done, and then we reverse that process. It's really, really a nice way to look at it. But let's take a look at letter B. All right, you did a lot of equation solving in 8th grade math, especially if you were in the Common Core program. And probably many teachers would have said, hey, look, if you're solving an equation like this, what you're going to do first and foremost is you're going to look to distribute, right? Use the distributive property to get rid of that parentheses. So pause the video now if you think you know how to do it that way, right? And then we'll take it from there. All right, let's go through it. So if I use the distributive property, right, and that's just all I'm doing when I do that. I'm not solving the equation, I'm just writing an equivalent expression. I would get -2 times x, which is, well, -2 times x. Then I would have -2 times, if you will, -4, and that will give me +8. That's a little bit tricky. Then I just have this other +8, right? I can now use the associative property of addition to decide, right? That's all. The associative property just says, hey, look, if I got a plus b plus c, I can add these two together, right? Now, of course, I might say, well, I'll just subtract 16 from both sides. Be careful here. 2 minus 16 would be a -14. And then maybe I'll divide by -2 on both sides. Remember, a negative divided by a negative is a positive. And look at that. I love it when I do math in two different ways and I get the same answer. You know, in part A, what we do is we identify what's been done to the variable and we undo it in the order in which it's been done. And that is always my preference. But a lot of times teachers say, hey, look, if there's a multiplication left undone, right, like -2 times x minus 4 that can easily be done using the distributive property, why not do it? Ultimately speaking, by the time we get down to this step, we're still doing what we're doing over here anyway, right? We're undoing the addition of 16, then we're undoing the multiplication by -2. So we still use this idea of reversing what's been done to x. We just do it a little bit later on in the problem. All right, so I'm going to scrub out the text. Pause the video now if you need to. All right, here we go. Nothing like a clear sheet. Let's move on. Okay, the last thing that we're going to work on today is oftentimes not a student's favorite, but we're going to work on trying to translate verbal phrases into equations and then solving those equations. Now, we had a lot of work in the first unit on translating verbal phrases into math. Hopefully this is where it starts to pay off. So let's take a look at letter A. Why don't you read that to yourself for a moment, and then I'm going to read it out loud. All right. 10 less than 5 times a number results in 35. 10 less than 5 times a number results in 35. What is the number? It's like a riddle. I love these, I really do. But you have to be so careful, right? Let's take a look at the structure of the sentence. 10 less than, right? 5 times a number. If I just had like 10 less than 35, that would be 25, right? So 10 less than means I'm subtracting, right? I'm making a number smaller. What number am I making smaller? Well, I'm making 5 times a number smaller, right? Results in 35. So, well, let's take 5 times a number, let's make it 10 smaller, and then let's make that result in the number 35, right? Think about that for a second. I encourage you to oftentimes think about the multiplication first, right? Think about, like, are we multiplying the number or are we multiplying some kind of sum or difference? Here we're taking a number, taking 5 times that number, finding 10 less than it, and getting 35. Now, of course, what's the number? Well, why don't you go ahead and pause the video and solve that pretty easy equation by identifying what's been done to the number and then reversing it. All right, let's go through it. Well, if we look at the structure of the left-hand side, right, what we've done is we've taken a number, multiplied it by 5, and then decreased it by 10. We're going to undo that. I'm not going to even list the steps anymore. I'm going to undo that by adding 10 on both sides, right? Put it up here. That's going to leave me with 45 on the right-hand side, and then I'll undo multiplying by 5 by dividing by 5. And I get n equals 9. All right. Notice it says check your answer for reasonableness. In other words, if I said, hey, take 9 and, find 5 times it and then decrease it by 10, right? You should be able to say, hey, look, okay, I can take 9 times 5, right? 5 times the number, and I can get 45. And then if I find 10 less than that, I get 35, right? And that's what I was supposed to get. So that's what I mean by check your answer for reasonableness, right? You often can do that in these problems. Let's take a look at B. It's a little bit trickier. Read over the text, and then I'll read it out loud to you. This one's a little bit harder. When 3 times the sum of a number, oh boy, is that an important phrase. The sum of a number and 7. When 3 times the sum of a number and 7 is increased by 10, the result is 4. Let's deal with this. The sum of a number and 7, right? Then what are we doing to the sum of the number and 7? We've got 3 times it. I really need those parentheses, right? Because if I don't have the parentheses there, I'm only going to be multiplying the number, n, right? Then we increase it by 10. So here it gives me this. This gives me this. The result is 4. Wow, look at that, right? The trickiest part here are these parentheses. Students will often leave them out, and they get the wrong answer. And it's not even a reasonable answer. Anyway, pause the video now, identify what's been done to n, undo it, and get an answer. All right, let's go through it. So what's been done to n? Well, we added 7 to it, we multiplied by 3, and we added 10. So let's undo that. Let's subtract 10 from both sides. Be careful, right? We have a 4 minus 10. Don't tell me that's 6. If I got 4 apples and I take away 10 apples, I have confusion. Negative numbers are weird. But I owe some 6 apples, right? Okay. Anyway, I have negative 6. Let's undo the fact that we multiplied by 3. Let's divide by 3 on both sides. going to leave us with our nice n plus 7. Watch out here, a negative divided by a positive is a negative. 6 divided by 3 is 2. So we get negative 2. Let me take the math up here. And then we'll subtract 7 from both sides. Again, be careful. Negative 2 minus 7 is going to be negative 9. What I would encourage you to do on all of the arithmetic is try your best to do it in your head. Really, try your best. And then check each step along the way with a calculator. I know that especially things with negatives and positives can be tricky. I know fractions can be tricky. It's really important that you be numerate, that you have the ability to work with numbers in your head independent of the black box. We'll talk about that more as the year goes on. But we get n equals negative 9. Hey, look at that. I got a positive 9, I have a negative 9. Anyway, I'm going to scrub out the text, so take a look if you need to. All right, here it goes. Okay, well, I want to thank you for joining me for another eMathInstruction Common Core Algebra 1 lesson. Remember, you can get the worksheet and the homework for this lesson by simply clicking on the video's description. As well, try out that QR code and tell us what you think. You know, we think it's going to be really helpful in the future for students to be able to scan that code and for teachers to be able to scan it. Of course, I'm a little bit nervous what happens when you photocopy it with a bad copy machine and some of the little squares get all mixed up. I got to think it won't work then, but I hope that you've got good photocopiers. Anyhow, for now, thank you again for joining me. Until next time, I'm Kirk Weiler. Keep thinking and keep solving problems.